So far we've talked about the shape of data. Remember, positive skew, negative skew, approximately symmetrical. We've also talked about measures of center. When we compare data, the last thing we comment on is the spread. So what the spread is a measure of the variability or variation in the size of the data values. To do spread or to get some summary statistics, what we can do is divide the ordered or ascending values for any numerical data into 4 quarters. Okay, so we separate out whatever the data is into 4 separate parts. The part between 0 and 25, this is called the lower quartile, okay, 0 to 25. The middle 50% is 25 to 75. Okay, and we've got the upper quartile 75 to 100. Okay, so that's really how we divide up the data is into 4 separate groups. There are 2 measures of spread that we commonly use, which is the range, which is only used for data sets with no outliers present and are not strongly skewed. Okay, now the next method that we use is what we call the interquartile range, which is, I call this one for all occasions. Okay, so the interquartile range can be used on data sets that are skewed or have outliers, or when they don't. All right, so what are they? Okay, so this first measure of spread, the range, is the difference between the highest and the lowest data values, and all you do is you remove the minimum value from the maximum value. Okay, what the interquartile range does is it's basically moves in 25% on either end and subtracts that value there. So it basically works out the value of the upper quartile, 75% mark, and the lower quartile, the 25% mark, and actually removes this value, the Q1, from the Q3. So it's very similar, but what it does is it avoids these maximum and minimum values, and that's fantastic if we've got an outlier. Now here's my example. Imagine I walked down the street, and what I did was I asked my neighbours, of which I've got, say, for argument's sake, 7 neighbours, and I asked them, hey, how many pets do you have? All right, so here's what I found out. Here's house 1, 2, 3, 4, 5, 6, and 7. So house 1, when I went over to house 1, what they said was they have, I don't know, 2 pets, 2 dogs or something like that. This house here had 0 pets, 1 pet, 3 pets, 2 pets, 1 pet. And this house 7 here, you know that one on the block that has like the car on blocks out the front, long grass, etc., etc. Knock on the door, crazy cat lady comes out, and what she's got, she claims, is 99 pets. Look up crazy cat lady from The Simpsons and you'll see what I'm talking about there. 99 pets. She's got 99 cats in the house. Okay. So if we were to say then, or summarize the spread of the data, what I would say is if I was using the range, I would say that that's the maximum value, take the minimum value. That in this case would be 99 take away 0 equals 99. My range is 99. That's actually true. When I surveyed the houses in my street, the values of which the number of pets had ranged was 99 values, okay, which indicates that it's really widely spread. But actually, it's not true because really, with the exception of this interesting house over here, the range actually is a lot lower. And if I was to use the interquartile range as a measure, we'd get a truer picture. So I'm going to put them in order, 1, 1, 2, 2, and 3. And what I'd be doing is instead of using these 3 and 99, instead of using these endpoints, what I would do is move in 25% in this direction and move in 25% in this direction. So I'm going to move those endpoints in and take the figures that are 25% of the way through and actually use those figures to calculate the range. And what it does is it chops out any possibility of these extreme values, crazy cat lady, etc., in the calculation. Right, so how do I find those 25 and 75% values? Well, this is the method we use. So determine the range, median, Q1, Q3, and IQR of the following data sets by hand and using the ClassPad calculator. Well, let's do this first one here. So what we're going to do, this is the basic process to find out all of these things. Now you can get the range straight away. So we've confirmed that the data is smallest to largest. So we're going to do range is max take min, which is in this case 20 take 2, which is 18. All right, now what we're going to do is get the median. Okay, the next stage of this process is to get the median. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the median pos can be found by doing n plus 1 on 2, which is 10 plus 1 on 2, which is 5.5. All right, so that means that the median is between the fifth and the sixth numbers. That's not the value of the median, that's where to go to get the values. So it's 1, 2, 3, 4, 5. There's the fifth and there's the sixth. So the value that is theoretically in between those values is our theoretical median, which in this case, it's easy, it's going to be 7. But if I wanted to confirm that calculation, 6 plus 8 is 14, 14 halved is equal to 7. So our median is 7. All right, now what we do when we've got no true median to find the Q1 and the Q3 is we essentially chop the two data sets into two separate parts or two even parts. What we're going to have is 5 on this side and 5 on this side. And then we treat the two data sets as two distinct sets of data, I suppose. So this data set here, what we're going to do is find the median of this part here. We want to get the median of that. So I've got 1, 2, 3, 4, 5. That's n plus 1 on 2. So median pos is n plus 1 on 2, which is 5 plus 1 on 2, which is 3. That means that it's the third item in there that gives us our median of this left side. And our median of this left side actually is Q1, because that's the piece of data that is 25% of the way through the data. So we've got 25%, 50%, and over here we just use this same median position calculation, except I just cut in from the end. So I go 1, 2, 3. This value here represents our Q3, okay, because it's 75% of the way through the data. So here we've got our minimum value, our Q1, 25% of the way through, our middle value, our 75% value, okay, our Q3, and our max value, 100% of the way through, is 20. All right, so let's write down our Q1 is equal to 4, our Q3 is equal to 13, and our IQR, the interquartile range, IQR equals Q3 take Q1. That is, in this case, 13 take away 4 equals 9. So there's our interquartile range, okay? So note that it's different from our range, and in this particular data set, either the range or the interquartile range would be an appropriate way of stating the spread, okay? Because there's no clear outliers, like 20 doesn't seem that unreasonable and 2 certainly doesn't. All right, what do we do for this data set here? Well, we're going to use the same approach. We've got 1, 2, 3, 4, 5, 6, 7, 8, and 9 pieces of data. Just take mental note of that. Our range is the max take away the min, which is 2.9 take away 1.6, which in this case is 2.61, 1.3. All right, now what we're going to do is grab our median, and it's going to be n plus 1 on 2, 10 on 2 is 5. Now remember, that is not the median, that's where to go to find the median, and if anyone claims that that could be the median 5, I'll be like, how could you get a middle value of 5 when the lowest number is 1.6 and the highest number is 2.9? Not possible, okay? So our median position tells us they want us to go to the 5th position, and the number that resides in that spot is our median. So we've got 1, 2, 3, 4, 5. There it is. Our median is 2.1. All right. Now, what we need to do is a similar break in the data sets like we did before, except we can't actually split 2.1. Like we can't put oh, let's put 2 on this side and 1 on this side or anything like that. So what we do when we get a actual median or a median that is not theoretical, it exists, is we actually remove it from the next considered calculation, which is the Q1 and the Q3, okay? So what we do is we use this number here to break the two sets into 2 parts or 2 even parts, but we don't include it, okay? Because if we include the 2.1 over here, this set has 5 and this has 4, or if we include it over here, 5 versus 4, and the sets have to be even when we split them into 2 parts. All right, so what we do basically, and the easiest way to do it is just to remove it from consideration. And then what we do is we've got 1, 2, 3, 4 over here, 1, 2, 3, 4 over here, all's fair. All right, so to get the Q1, what I do is I work out how many numbers I've got. So I'm going to work out the median of this left side here. So I can see it, but I'm just going to do the calculation anyway. So median pos is 4 plus 1 on 2, which is 2.5. And that means it's the second and the third values that will tell us the middle value there. So what I'm looking for is the middle of 1.7 and 1.9, and that's going to be the Q1. Over here, we're going to get the first, second, and third, the middle of the second and the third. It's the value between 2.4 and 2.7. So Q1 in this case is 1.8. Our Q3 in this case is equal to, halfway between that is 2.5, what's that, 0.3, 1.5, 2.55, I think. Let's just quickly do that on the calculator so I'm not getting you to write down something silly. 2.4 plus 2.7, and we're going to halve that result. Good, I can do basic arithmetic. So there's my Q1 and my Q3, and what we're going to do is calculate the IQR, the interquartile range, by doing 2.55 take away 1.8, which is equal to 0.75, I believe. 275. Again, I just want to make sure that I get that right because I don't want to upload a video that's got errors in it. Good. All right, so there's my summary statistics there. So I can get the range, the IQR, the Q1 and the Q3. All right, we've seen already, girls, that there can be things like outliers in data. And going back to this original example, 99, that house on the block with, you know, all the cats and all that sort of stuff, that's an outlier, okay? Now, in mathematics, we can't sort of just use gut feeling because you might think, oh, that 99, it's not that unusual. Whereas I go, yeah, it is unusual. Who wins? What do we do? Like toss a coin to decide? Arm wrestle? No, what we do is we use, it's called the Outlier Test, okay? So what we do in mathematics is we set up what we call these fences. And the fences are basically values that we establish, and we say that anything below this fence or above this fence here would be considered outliers, okay? Now the fence values, it says here in the notes, are not necessarily a value found in the data set. Okay, so all it is, these things here are theoretical values that both you and I will agree that anything outside of these values here, we're gonna say that they're an outlier. And that way you and I don't have to have an arm wrestle to try and decide who is correct, which one of us is correct about it being an outlier. We just run the fence check and that establishes the rules of the game, I suppose. All right. So let's go through and do this question. And what we're going to do is see whether this data set has got any outliers whatsoever. I know that the previous question also said use the calculator to do it. We'll use the calculator to help us out with this one as well. Right, so determine the range, median, Q1, Q3, and IQR of this data here. All right, so what we're going to do first of all is get the calculator to put the data in order for us, smallest to largest. So we've got 5, 1, 2, 6, 3, 3, 18, 4, 4, 1, 7, 2, and 4. And remember, we go edit, sort in ascending order. Okay, so let's just write it down in order. So we got 1, 1, 2, 2, 3, 3, 4, 4, 4, 5, 6, 7, finally 18. Let's just check I've written that in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, now it's good to note what we're actually doing. So this is like the number of flying geese spotted on each day of a 13-day tour of England. So just say I'm like mad keen on geese. Okay, I love geese. And I go on this tour to spot flying geese, right? On the first day, spotted 5 geese, good day. Second day, spotted 1 geese, pretty slow day that. Blah, blah, blah. So this day here, whoa, 18 geese in the sky, like that is amazing. That's what I paid my money for, okay? So that's what we're looking at here. So make sure whenever you get one of these problems here, try to imagine the data set, what it represents, and get an idea of how it works. All right, so the next thing we're going to do is get the range. So that's 18 take away 1 equals 17. Our median, we've got to get that before we get the IQR, because the IQR needs the Q1 and the Q3, and the Q1 and the Q3 are dependent on how the median is found. So the median POS, remember, is n plus 1 on 2. We've got 13, so is 13 plus 1 on 2, which is equal to 7. 1, 2, 3, 4, 5, 6, 7. There's our median right there, it's 4. So median is 4. Okay, now because we've got a direct median, what we do is we exclude that from the data set and divide the data set into 2 even parts on the left and the right of the median. So we've got 1, 2, 3, 4, 5, 6. Okay, so again, we're going to do another median position calculator. 6 plus 1 on 2, which is 3.5. So that means it's between the third and the fourth. 1, 2, 3, there's the third, and there's the fourth. So Q1 would be the value in the middle of 2 and 2, which I hope you realise would be 2. Right, over here we're going to go 1, 2, 3, the middle value between 5 and 6. Q3 is going to be 5.5. All right, and the IQR is equal to 5.5, the Q3, take away the Q1, which is 3.5. Calculate the value of the lower and upper fences to justify whether outliers exist. So I'm predicting that this 18 is probably an outlier, okay? That would be like the day, oh, so unusual. Oh, we saw 18 flying geese. You wouldn't believe it. It was just crazy. All right, the next highest value is 7. 7 from 5 does 6. It doesn't seem that unusual. So I'm predicting that 7 is not an outlier, okay? So in the upper fence, I think 18 will be above the upper fence. Now the lowest value is 1. That doesn't seem unusual. I think the lower fence will be below 1. Okay, let's do it. So the lower fence can be calculated by doing, or finding the Q1, and you do 1.5 times the interquartile range. Okay, so that's how we do that. 1.5 times the interquartile range, remove it from the Q1 value. So the Q1 is 2, take away 1.5 times 3.5. Bit of decimal work here, and we're going to go over to the calc and get it to help us out with that. So 1.5 times 3.5 is 5.25. We're going to do 2 take away 5.25, and note that the lower fence is negative 3.25. So anything below negative 3.25 would be considered an outlier. And in this case, we know it's just not possible, okay, because you can't see like negative 3 geese. It's just not going to work. Okay, so let's do the upper fence. Q3 plus 1.5 times the IQR. Just use the formula sheet for that one. Taught further maths for a few years now, and like I just remember that formula. Okay, so the Q3 is 5.5 plus, we've already got the answer to 1.5 times 3.5, which is 5.25, which is 10.75. All right, so clearly 18 is an outlier, okay? So what we're going to say is 18 is greater than 10.75. Therefore, 18 is an outlier. Right? 7 is not. So make sure if you're going to claim something as an outlier, you must put this line here as evidence. You can't work out the fences and then say, therefore 18 is an outlier. You've got to explain why. That's a classic further maths question. They do that one every single year, so just watch out for that one. So give a possible reason why outliers may have occurred. So this one's hard, okay, and you're not supposed to be experts on this, but you can speculate on the data, okay? So why did 18 occur? And I'm thinking here that because it's a 13-day tour of England and England's notorious for having pretty dodgy weather, that this might have been the only fine day. So 18 geese flew on the only fine day. Okay, you're not supposed to know that. This question here generally will not get asked in any form in a maths test. You're not supposed to be like a bird geese expert or anything like that, but I'm just speculating here that that might have been the case, okay? They might have gone to a nicer spot or a more popular spot on that day. That might have been when some birds were migrating, okay? So that was a big day, I don't know. Explain which of the range and IQR is a more accurate measure of spread for this data and mean or median is the most accurate measure of centre. Well, girls, we need to use the IQR for this data, okay? Because if I claim that the range is 17, then that's kind of phony because what that means, it gives a false impression of the data set really, because what it says is like the number of birds ranged at 17. It sort of indicates that there's a really wide range, but it's actually not. Like if you look at this, the data, the highest value other than 18 is 7, the lowest value is 1, okay? And so this 18 really pulls out this range value and kind of gives you a false sense of the data. So in this case here, the IQR has to be used because of the existence of an outlier. All right, so we're going to use the IQR rather than the range because of the existence of the outlier. Now, we can then report on the mean or the median if I was to measure the center of the data. And I hope you know that we're also going to use the median because of exactly the same reason. There's an outlier. The outlier would be included in the mean, okay? So if I was calculating the mean or average, that would be included, the 18. But the median, remember, I could have seen 10,000 ducks on that day, like the mass migration of the ducks or something, and it still would have meant that the center of the data would have been 4, okay? So that could have been 10,000, 100,000, okay? And that would have been 4. But if that's 100,000, then the mean will just spiral out of control. It'll be huge, okay? So in this case, the median also because of the existence of the outlier. All right. So this is a further maths question here. The development index for each country is a whole number between 0 and 100. The dot plot below displays the values of the developmental index for each of the 28 countries that has a high development index, okay? So whatever it is, the development index just represents, I don't know how affluent the country is or how prosperous the country is. I don't really know. Using the dot plot, determine each of the following. So the mode. The mode is the most frequently occurring number. That's pretty easy. 1, 2, 3, 4, 5, 6, 7 beats any other dot. So a mode in this case is 78. That's the most frequently occurring development index. The range. The range is the max, take away the min. So the highest value is 79, it occurred twice, but that's neither here nor there. And the lowest value is 70, which equals 9. So a range in this case will be 9. So 1 mark, fairly easy problem, that one early on in the paper. All right, the dot plot below shows the distribution of daily rainfall in millimetres at a weather station for 30 days in September. Write down the range. Okay, so what the range is the max, take away the min. All right, and then if we look at this dot here, we can see here that that's going to be 17.2, 17.4, 17.6, 17.8. So this is going to be 17.8, take away the lowest value here, which is 0, which is 17.8. Right, the median is the middle value. So what we're going to do is work out the median pos equals n plus 1 on 2. Now, VCAR always gives you the numbers here. So 30 plus 1 on 2 is 15.5. So our median can be sourced by going to the 15th and the 16th piece of data. So let's go in order. We've got 1, 2, 3. I'm just going to color in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The middle value between these two values here. So the median is actually 0. Okay, because the middle value of 0 and 0 is obviously 0. Circle the data point on the dot plot above that corresponds to the third quartile. All right, so what we would do then is we're going to note first of all that there was 30 values, okay? And because there was a theoretical median, what that means is the 30 values are going to split evenly, 15 on the left side, 15 on the right side. The third quartile, we're going to work out where I would find that. If there's 15 numbers on the right-hand side, we're going to do 15 plus 1 on 2, which is 16 on 2, which is 8. It's the 8th number. All right, so 1, 2, 3, 4, 5, 6, 7, 8. There it is right there. That's the median. Okay, write down the number of days on which no rainfall was recorded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the number of days on which no rainfall was recorded is 16. The percentage of days on which the daily rainfall exceeded or was more than 12 millimeters. So here's 12 millimeters here, and we're looking for all of the days above that, of which we've got 1, 2, 3. So that's 3 out of the 30 multiplied by 100, okay, which is going to be like 300 over 30 equals 10%. All right, so your work today is from exercise 9C. So use all of the skills you've learned today to complete that exercise.